some ways. I'll make it a bit warmer. Well, not really, but if you really have to, I suppose. Okay. Oh, you won't need it today. You're going to be sitting down. Oh, we better go outside. There'll be some books out there. They can't come in though. They're not supposed to be coming in here.
Oh, okay.
Because we're doing this. No, it doesn't anymore. But they'll have to. Well, they can sit outside there, I suppose. You'll need to just sit over there. Can you start by taking out this sheet that we were looking at the other day? We're going to be looking at something a bit similar today. Just have a look at the bit down here for a moment where it says present your findings. I did print out a few of the things that you've been doing on the computer, and they're sitting over there. There's a few snowmen or snow people. There's a herd for circle. There's a smiley face reflected. And there's 2 or 3 of the things that you've been doing with the star in the circle. And it actually doesn't print out in a way that you can read it from very far away. It's all right to look at in front of you. And it doesn't print out in colour either. But this one has, firstly, the diagram. Up here it has the measurements of the angles plus the formula. And that person, and also the one next to it, has written some sort of a conclusion, which is what's being talked about here. That's one of them. Now, this actually is quite easy to read, but it doesn't project all that well. So let me read it for you. The sum of the angles don't change when you move the points around the circle. When you change the radius of the circle, the size of the circle changes and moves in and out. No matter what the size of the angles are, if you have a 5-pointed star inscribed in a circle, it will be 180 degrees. So there's actually a few things mentioned in there. There's the fact that it's 180 degrees. There's the fact that it doesn't change if you move the points around the circle. there's the fact that it doesn't change if you change the radius of the circle. So this person has put in a conclusion to do with several of the things that were mentioned on there. Quite a lot of you haven't yet got to that stage of writing all of those things onto your page. What I want to do now is, if you can pass these back. Firstly, everyone just individually read through the page, please. Okay, that's enough for just a quick read through. Now I'd like you, together with the person next to you, to read through it and have a look at any words in there that you think we might need to know the meaning of. Just underline them with a pencil or something like that. They could be words that you're not sure of the meaning of, or they could be words that maybe you do know, but you think, yeah, that's a pretty important word for us to do. Let's do this with a brief discussion with the person next to you, please. Well, we'll cover that later, but what it would mean would be that if these rays, instead of going in that direction, if they went in the opposite direction. Okay, people have found a few words. They seem to be the same words. Can someone give me a word or two that you need? Okay, convex. Where's that? Okay, it's in several places, but there's one of them. There's another one. So there's convex. Certainly must be important since it occurs more than once.
Quadrilateral.
Okay, we've got quadrilateral.
Polygon.
Okay, polygons. The actual heading says polygon, doesn't it? So if you certainly need to look in the heading. Some others, words or phrases?
Exterior angle.
Okay, who had exterior angle picked out as something that they need to know about? Okay, so exterior angle, polygon, convex, quadrilateral. They were the main ones I saw when I looked around. Were there any others? Rays, okay. Okay, it says construct rays, so that's something that we need to know about as well. Okay. Let's have a look at these words. Polygon. Can anyone help us with what a polygon might be?
Five-sided shape.
Five-sided shape? Who agrees with a five-sided shape? Well, not a lot. Any 2D shape? Okay, so would that be a polygon?
Any 2D shape which is enclosed.
Oh, that's enclosed.
A many-sided shape.
Many-sided shape. Ah, straight. Okay, that's getting a bit closer to it. So a shape that has a number of straight sides. How many sides has that got? 6. What's it called if it has 6 straight sides? Hexagon. The diagram up there has in the middle of it what sort of shape? Pentagon, because it has 5 sides. If it polygon is just the name for any number of sides. Now, exterior angles, there is something there that tells you what an exterior angle is. Who's found the spot that actually tells you on the page what an exterior angle is? Here?
An exterior angle lies outside the polygon.
Okay. Exterior angles lie outside the polygon. It says that in the second sentence underneath the heading. What does the first sentence underneath the heading say?
Exterior angles of the polygon is formed when one of the sides is extended.
Right. It's formed when one of the sides is extended. So suppose I took that side. What choice have I got about extending it? Emma? Okay, you can go in 2 directions, but suppose we choose to go down, then I've turned it into a ray now, haven't I? Because it goes on in one direction. The exterior angle is the bit that's formed in there. And it does lie outside the original polygon, does it? Yes, it certainly does. How many of those could you get from this hexagon? You could get 6 of them because there are 6 sides to extend. And you can see from the diagram that you've got on your page that they've all been extended in the same direction. Someone asked about this note down here. This construction creates only one set of exterior angles. Another set could be constructed if you went the opposite direction with your rays. So I could have gone all of them around in that direction, but we just choose one direction. Okay, we'll be moving across to the computer soon, and you'll be doing that construction. It gives you some fairly specific things to do first. Just think about how this is going to be constructed and read what it says there. How do you actually construct that diagram? Okay, first thing is you need to go to the segment toolbar and change it to array because you want to draw rays rather than segments. And then
Start at one point and then go create a ray and then do somewhere along that ray and make another one across.
okay, just listen carefully to what he said there. You create one ray. Let me get rid of this and start again. It'll look like that, won't it? Okay, now the next thing he said was you go somewhere along that ray and do another one. Now think carefully about that.
You go to the point.
Right, you actually start at this point that's already there. You don't pick a point somewhere else. Start at that point to make sure that the new one you draw is joined onto the old one rather than separate. So you actually start with that one. When you read through this, you'll see that it does all of that. Now, what haven't we explained yet? Convex. Anyone know what convex is? Anyone know there's a word that's the opposite of convex?
convex means like when you have glasses, there's either like a bended kind of lens or a straight lens, and the convex lens is the one which is curved.
Curved, yes. Curved which way? That's the key thing. Yeah, curved inside. The other word that means the opposite of that also starts with that. Concave, yeah. Now, convex polygon is the sort we just drew, but for example, a concave polygon looks like that. And the easy way to remember it is that it's part of it is caved in. Okay, it's pointing inwards. Convex polygon, everything is pointing outwards. So you have to make sure that your polygons stay like that. The investigation is to find out something about these exterior angles, and you're starting off with 5 of them. In the space up here, just write down what you think might be something, a fact that you might discover about those angles. There are some sentences starting, I think that all of the exterior angles will. Some people are getting a bit more specific than that. Some people are saying they may, hedging their bets a little bit. Take a guess anyway, because it doesn't matter if you're wrong, but it will be interesting to test and see if you're correct. Okay, there's a few different ideas written down there, and we'll actually have a look at everyone's later on, but for the moment it's just you thinking about your own one and seeing whether it proves to be correct or not. What's that sort of thing called that you've just written down? Okay, it's another word beginning with those things. Okay, so we have a conjecture, but we haven't really got any evidence yet, so now we're going to have a look for some evidence. Okay, oh, make sure your name's written on the page. I see most people have already, just in case it goes astray. Now, you'll be working at the computers in groups of 2 or maybe 3. The computer that wasn't working yesterday has decided it's much happier about working today, so they are all working. So if you'd like to do that. Notice I've fixed up.
Yes, thank you.
Hey, wow, that's quick.
Oh, you spelled my name.
Wow, there's a pentagon already.
Wow.
Oh. How come they do what? Oh, yeah. But now be careful of what I was saying before. Rather than using that point, you need to use the one that's already on there. So how do we get rid of that one? Is there a way to undo that thing? Yeah, okay. You can move that along a little bit, and then go back to that, and then start from that one when you do your next one. Yeah, that's good. You can make it a bit bigger, but it should click onto that last one.
Oh, wicked.
Just make sure they're joined. Get rid of that one. And use the pointer tool just to make sure that it's all joined together. Move them around a bit and make sure they stay. No, that's not joined down.
I'm just going to go and hold down shift. Yeah, keep going all around. Sorry. Okay, now.
Yeah.
It's all convex. Is it all convex?
Yes.
If you go down to there, just move the pointer down. It should join up. And move
Wait, we have to name the point. What have you done with that?
where. Yeah, Command Z. That's right. Oh, no, you don't want this to join up to that one yet, do you? No, that's true. You know what you're doing here, I don't.
Now we construct
That's fine, actually.
on AV.
Is that the link? Is it or what?
Oh, no. Start new.
See, what's happened here is you didn't quite.
Oh, I didn't want untied. Okay. Oh, we will get it to raise.
Start the next
Okay,
one
I'll do it like those.
there.
Each of these. Choose a minute.
And then that makes sure they're joined on if you do that rather than having separate ones. I'll just test this one for me. Just make sure they're all joined on. See, that's not really quite joined on. You've got too many points there. That's the trouble. What you need to do with the second one is actually start with the point that's already on it. And then your next one start with the point that's already on it. You can also move it around so it looks a bit bigger, like so. Go back to that, and then start with that point, and they're all joined nicely. Okay, let's just check. Are they nicely joined? Seems to be quite nicely joined.
Our pentagon is convex.
Okay. Now, see what it says here. You've done that. On the rays, outside of the pentagon, construct points. So we need to construct some points outside. And we need those.
Oh, Maggie.
So we can talk about the angles. Right, now to measure the angles, you go that. No, that's one of the exterior angles, isn't it? Okay, so now we can measure the angle. Okay, then do the same.
Okay, now we
So that one.
measure the angles.
I think they're going in the wrong direction. See, all these are going around that way, and that one's going off in that direction. Can we just? Suppose we draw it over like so. See how now they're all going around in the same direction, like the diagram? That's a good one.
No, rather than like 1 and 300.
How are we going with our... Yeah, that's looking good so far. Hang on. Oh, what you've got to do, cancel that. You've actually got to select these things before you can do the formula. So you do that, then you go calculate, and then you can have that angle plus that angle plus. No, that's what it says in step 3. On the rays outside of the pentagon, construct points. So you just got to select the point tool and click somewhere out there.
Okay, now we need to put points out.
Otherwise you can't do that. You might need the point tool. That's good, and then just make sure it joins up. Yes, that's good.
Last time I went laboring, it's more like right. And then that one next, that one? No, you did that one first.
It doesn't matter if they're not labelled in exactly the same way, as long as they've got labels. I think you might need the select tool.
I mean CBD. Do you just measure the exterior or the inside ones?
Well, no, because it's all about the exterior angles, isn't it? So we don't really want to know anything about the interior ones. Now, do you remember how to measure the angle?
Yeah, that's
That should be okay. That should be okay. Remember, click somewhere to get rid of the other selection and then go but. Do you remember how to measure the angles?
Yeah.
After you've got something good like a diagram with a pentagon and maybe a formula even, you might probably save that. Just it's a good idea to save things. Call it exterior angle pentagon. So then if you do some other exterior angles, you can give it similar names. Okay, so do they change? Okay. What about if you make it concave? Yeah, once it's concave, it doesn't stay. Yep. Point 2.
It's weird, if you move these two, it seems to change.
Just show all the labels. A, B, C, D, E. A, B, C. And you've got angle G, H, E.
Let's do the middle one first.
Yeah, because you've actually measured angle D, H, E, which is that angle over there. You've got to go like that. You can easily check up by the vertices because you should have angle A, B, C, D, E. Look in the middle. A, B, C. H, so that one there needs to be changed, but it'll mean you'll have to change your formula as well.
Start again. Just get rid of all the labels.
It's easier to understand, so Ken our forest. How did you do it the other day when you just clicked on the things and
Okay, you think, yeah, you've got to go back one stage because you have to select the measurements you want in your formula before you do it. Now when you go to calculate, you can say that angle plus the second one plus and so on.
thank you. I just pressed the thing.
Yes, excellent idea.
Does it matter if it goes through the rays?
No, you've got room in the corner there to write it. You remember how to do that? I think you have to select the little hand and then do what you just did. Yeah, now you can write. Now, let me see. This in this area. Now look in the middle, you've got this you've got one with J.
Oh, we measured that one. It does something.
So, yeah, you want that one, which means you're going to have to change the formula as well. Oh, triangles too. Have you saved what you've been doing? It's good. People, can you just turn around and face me for a moment, please? Most people are getting to have the formula, and in most cases you're finding a reasonable looking result. If you get something that looks a bit strange, it could well be that you haven't measured exactly the right angles, and I'll help you check that. Once you've got a conclusion from your formula, then you can write about it somewhere on that sheet. If you haven't got up to finding out how to do a text box yet, just ask me and I'll show you how to do that. Okay? Well, which polygons have you tried so far? You've only tried a pentagon. Okay, so if it said what is the sum, the measure is just the size really, which is what you found, so it's just the sum of the angles really, exterior angles. Now for the pentagon it turned out to be 360 degrees. Now they're asking you, assuming you've also done triangles, quadrilaterals, hexagons and so on, now what's your conclusion? Does the total go up perhaps as you add to the number of sides, or what happens? That's what it's asking you to write down about. What did you do then? Oh, can you do it again? Oh. So the top of it is slightly off the screen because you haven't got your thing there, have you? Should work if you drag the edge of it, and that should just make it nicely fill up the screen if you click on that. Okay, now you're going to write something about it now? Do you know how to do that? Yes, I think so. Now, your conclusion says when you move the parts of the pentagon, the sum of the angles does not change. Okay, so exterior angles would be a good thing to add in there. And one other fairly important fact that you could mention.
We haven't finished yet, and we're just going to change it. We have to find out.
Okay, but just think about when you say it does not change, what doesn't it change from?
Oh, yeah, I see what you mean.
Text box, use this one, and you just drag it where you want the box, and then you get a usual sort of insertion point, you can start typing. If you look at that angle there, is that angle IBC? Is that what it says? Okay, now if we trace angle IBC, it goes from there to there to there. Now, is that one of the exterior angles of the polygon? In fact, what would you really call it? Interior angle. Are all the other ones the same?
Yeah, they are like that.
Yeah, so
I measured the interior.
236.
oh. Will we get the computer to do that for us? Can I just do this? Before you do that, you just need to select the angles that you want, or any other measurements for that matter, and go calculate. Now what it allows you to do is you say that angle plus that angle plus, and it will actually build it up for you like so. Good question. Let me try. I'm not sure if you can very easily. Things there. Maybe that looks like a degree sign. There. Hopcar.
Oh, and another question. This, do we have to go into a new sketch and make other?
Yeah, that's what they're asking about down here, where they talk about some of the measurements in these polygons. They're talking about ones because if you have more sides, you might get a higher total, mightn't you? So.
Mr. Brown, do we have to go on? Oh, I've got it. Do we have to
I'm trying to read that. When you move parts of the pentagon, angles change in degrees, but this does not affect the sum. Yes, the sum of the exterior angles are the same in any convex polygon. Oh, yeah. I'd sort of maybe suggest that you put the bit about the 360 degrees first, and then say, and this doesn't change if you change the polygon. But yeah, it's good. Yes, I don't think we'll really have time to do much of that today though, but save this one before you go any further, and that's probably about what we're going to have time for.
Really?
People, I think we're going to have to finish off for now, so if you haven't already saved, you need to save it at this stage. If you've saved it before, then resave it just to get the most up-to-date thing. We'll come back to that later. Can you save and close off, log out, and if you go back to your seats in the middle of the room, please. When you're choosing a name for it, try and choose a name that actually means something.
And I had to try
Brown. When we used the computer calculator, it got 360, and when we did it on my calculator, it's 359.
Yeah, the reason probably is these ones are rounded off slightly. Now the computer probably knows that that's really 90.2 and that's really 73.1. So it hasn't displayed the decimals, but it's sort of got it in its memory and it's included that in the total as well. Pack up, yes you can pack up. People, just before you go, we got about as far as I thought we would in that amount of time, and obviously that's only about halfway through the thing, but just before you go, who found that their conjecture or prediction was confirmed by what they did? Now not everyone had a prediction that the total was going to be 360, some predicted 180. A few people had quite different predictions such that all the angles will be less than 90 degrees, which is another one. Others might not have thought of that one, but you could test that conjecture as well. Okay, we'll be continuing on with this at a later stage. Or something.